Okay, so another S block chemistry question. So they're asking which one is true with regard to S block elements. Okay, so they are asking from lithium to cesium of group 1 and beryllium to barium. So all elements in group 1 and 2 react with water. So what about beryllium? You know, its reactivity with water is very poor. So this is wrong. All elements in group 1 react with N2 gases. So if you think about group 1, so only lithium is going to react with nitrogen. So this is wrong. Magnesium react with both dilute and concentrated H2SO4 to give H2NSO2. So this is what I have given you. Normally think about the activity series. And when you have this activity series, this is a normal theory part that I discuss with students in class. So when you have HCl, metals above hydrogen except lead reacts with either diluted HCl or concentrated HCl to give H2 gas. So this is the activity series. So when you have the activity series like this, okay, zinc, iron, I'm not going to write everything. So there is lead here at one point, and there will be hydrogen, and there will be copper. So the idea is from hydrogen, the voltage is 0. When you go for copper, the potential becomes positive. So above, all are mostly negative. So these negative, from these negative elements with acids except lead, all these react with acids in principle. So here it will give the chloride and H2O with HCl, either diluted or concentrated. So when you use diluted or either concentrated acid in the activity series, above hydrogen except lead, all other elements basically gives chloride and emit hydrogen gas. But this is with HCl. But when you go for sulfuric, always remember sulfuric acid, again, there will be different reaction with the diluted one as well as the concentrated one. Okay, so we will discuss that. With the diluted, again, it is very similar to the concentrated or diluted of HCl. So you can imagine the metals above hydrogen, okay, except lead, reacts with diluted H2SO4 to give H2 gas. Okay, so this reaction is very similar to either conc or diluted HCl, which produces H2 gas. Here also H2 gas is produced when you react this with diluted H2SO4. Okay, but when you go for concentrated acid, conc H2SO4, all metals except aurum and platinum. So this will be gold and platinum at the bottom. So here you have copper, and then you have mercury, makara, silver, rataram parts. We say makara, silver, rataram parts. So this is very common. Small. You have many songs to remember this. You, as you wish, you can remember simply the reactivity of these elements by using this concept. So when you use dilute H2SO4, all these elements, for an example, here they are considering about, for an example, magnesium. They will react with diluted HCSO4 to form H2 gas, and with conc acid, except these aurum and platinum, all elements will react to form SO2 gas. You see here? And here in this box, it shows the oxidizing ability of H2SO4. Here, when you have H2SO4, first it will break down into SO2, H2O, and atomic oxygen. And this atomic oxygen will added to this copper to form copper oxide, which is the oxidation. Okay, so sulfur dioxide is present in this first step. Anyway, this is not very much essential to answer our question. The idea is magnesium react with both dilute and concentrated H2SO4 to give H2 gas and SO2 gas. So to know this is correct, you should know this one. So this is important. Trying to keep this in your mind. Okay. And the lithium with air forms a mixture of Li2O, yes, LiO2 and Li3N. These two are correct, but LiO2 is not there actually, because lithium oxide is the dominant form and mostly it is oxide. But for sodium, it is peroxide can be there. Okay, so don't put it. And this is superoxide, which is not common for lithium. It's wrong. All elements in group with one react with hydrogen gas and form covalent hydride. So this is also very important to understand. This is not always true because considering about the beryllium one, it is in group 2 in fact. But when you consider about even with group 1 lithium hydride, there is it's still those are ionic in nature, right? So covalent is not very common for group 1 and group 2, except you can consider about beryllium hydride, which is like the aluminium chloride, which is in dimer form. Al2Cl6 is forming. BaH2 also can form many different compounds with different valencies. Okay. If you know your theory well, this is very straightforward to know this one. Otherwise, go with this discussion. Take points from this discussion. Okay.